Normal approximations to the binomial. In the section on the history of the normal distribution, we saw that the binomial distribution can be used to approximate the normal distribution. This section shows how to compute these approximations. Let's begin with an example. Assume you have a fair coin and wish to know the probability that you would get 8 heads out of 10 flips. The binomial distribution has a mean of n pi. Since there are 10 coin flips, n equals 10. The probability of a head on any given flip is 0.5. So pi is 0.5. The mean is therefore 10 times 0.5, which equals to be 5. The variance is n pi times 1 minus pi, which equals to be 10 times 0.5 times 0.5, which equals 2.5. The standard deviation is 1.5811. Recall that the distribution has a mean of 5 and a standard deviation of 1.5811. A total of 8 heads is quantity of 8 minus 5 over 1.5811, which equals to be 1.8973, standard deviations above the mean of the distribution. The question then is, what is the probability of getting the value exactly 1.8973 standard deviations above the mean? You may be surprised to learn that the answer is 0. The probability of any one specific point is 0. The problem is that the binomial distribution is a discrete probability distribution, whereas the normal distribution is a continuous distribution. The solution is to round off and consider any value from 7.5 to 8.5 to represent an outcome of 8 heads. Using this approach, we figure out the area under a normal curve from 7.5 to 8.5. The shaded area is an approximation of the probability of obtaining 8 heads. To find the probability, you first find the area below 7.5. The z for 7.5 is computed by subtracting the mean of 5 from 7.5 and dividing by the standard deviation of 1.5811. This gives a z of 1.58. A z-table, or the normal calculator, shows that the proportion of the normal distribution below 1.58 is 0.943. The area below 8.5 is calculated in a similar way and is equal to 0.987. The area between 7.5 and 8.5 can be found by subtraction 0.987 minus 0.943, which equals to be 0.044. So, the probability of getting exactly 8 heads out of 10 flips is 0.044. The same logic applies when calculating the probability of a range of outcomes. For example, to calculate the probability of 8 to 10 flips, calculate the area from 8.5 to 10.5.